Learning target 2.3, I know atomic radius increases right to left across a period and down a row. All right, so the first thing you got to know about this learning target is what the atomic radius is. Right? For an atom, well, let's start with the word radius. Okay, atomic radius. If you recall from math, radius is normally the distance between the center of a circle to the outside, right? This is your radius. Now, in an atom, let's imagine an atom. So we have the center of the atom, which is the nucleus. Where does an atom end? That's a legit question. Where does an atom end? Well, it sort of kind of doesn't, because all around the outside of the atom, or outside of the nucleus, are my electrons, and they're just whizzing about. So, interesting fact, the way that you would measure the atomic radius, well, maybe not so interesting to you, but interesting to me, is you look at the distance between two nuclei, and you divide it in half. And this would be your radius. Okay, so just something for you to think about. Anywho, for this, I know atomic radius. I'm going to draw out a very crude version of the periodic table. If you watch all of the learning targets from Learning Targets 2, you're probably going to learn how to draw a very crude periodic table as well. Okay, so again, periods are left to right, groups go down, right? Periods, think of it being at the end of a sentence, and for the most part, most of us read from left to right, right, horizontal, and groups are up and down like a column. Okay, now, what you guys need to know is that your largest atoms are here. Your smallest atoms are here, right? Let's take a look at why. So basically, the atomic radius will get bigger as you go down, and it'll get smaller as you go across, okay? So according to this learning target, it would just get larger this way, okay? Here's why, right? It's all about the idea of control. So if you actually go down a group, when you go down a group, you're adding a new electron shell each time. So here's my nucleus, right? Let's start with lithium. Lithium has 2 and 3 third shell. And here's lithium. Now, the one right below lithium is sodium, right? Here's the nucleus of sodium. You look at the total number of electrons, it's going to be 11. So it has 2 shells, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and an 11th one. So if I keep going down this group, I'm just going to notice that each successive element is going to add a new shell. Well, if you're adding a new layer to something, it's going to get bigger, right? You put 3 layers of clothes on, or 3 jackets on versus no jacket, you're obviously going to be bigger wearing the jackets. Okay, this is an idea that's called shielding. The electrons in the center are shielding or keeping the nucleus from getting a hold of the electrons on the outside. Okay. Now, if you're going from left to right across a period, turns out, I'm going to do this on this side, turns out that you're adding more protons as you go across, but you're not adding a new shell like you are when you go down a group. So really, it's like imagining that in the center you have a whole bunch of teachers, right? And on the outside, there's you and your friend, and your other friend, and your other friend, right? Which has more control? Well, when you add more teachers, even if you're adding students around the outside, you have 1 teacher per student. That's more control. The teachers can hold it closer, right? You're not adding new shells where students can just wander off. You're all adding within the same shell, right? So going this way, it's going to get smaller because you're adding more protons, but you're not adding new shells, Okay, so there's no shielding. So given this information, let's go ahead and do a practice problem. Here's your practice problem. You're going to arrange the following elements in order of increasing atomic radius, meaning the atom's size gets bigger. Okay, you have RB, K, Na, and Li. So first thing you do, look at the reference sheet. Here's my reference sheet. Let me go ahead and find RB, K, Na, and Li. RB, K, Na, Li. All right. So what you should notice is these four are in the same group. If they're in the same group, what was the trend when they're in the same group? The trend was it gets larger as you go down a group, right? So I want to list them in order of increasing atomic radius. So my smallest one is going to go first. So my smallest one is actually the one at the top, Li. Li is the smallest, followed by Na, followed by K. Finally, RB is going to be my biggest one because it has the most shields, it has the most shielding, and it has the most shells. Okay. What you might see is something like this. Don't forget that just means that this is the largest one, this is the smallest one.